So good afternoon, everybody. Welcome to my next talk. It's a talk that's changed title several times. I thought I was going to look at meat myths and fibre fallacies, but I realised I know more about fibre than I thought. So the talk is going to be just on fibre in terms of specific foods. But actually, the first part of the talk is a little bit indulgent for me in the sense that I used to be a statistician, and one of the things I found in my own nutritional journey is how much statistics has been abused in a way to give us the message about what we should eat, what we shouldn't eat, what's good for us, what's bad for us, what constitutes a healthy diet, and what constitutes an unhealthy diet. So today is a talk in two parts. The first part, I'll be looking at nutritional studies, and in particular, chasing those things that you'll see in the paper where the headline starts, study shows. And then if I go on and talk about some food substance today is good for you, and then next week or tomorrow you'll see another headline, study shows, and that same food substance is then bad for you. So I'll be looking a little bit in more detail at those sorts of studies, what's behind them, really from the perspective in terms of nutritional journey and nutritional understanding. And particularly if you embark on nutritional change based on the material in these talks, you will come across headlines that seem to be doubting that is the right way ahead. And so I want to give you some insight into when you see one of these study shows headlines, how do you know? How do you know, is this something that's meaningful or is this something that's going to throw a curveball? How do you try and make sense of all these studies that come along that seem to contradict? You get one idea of how to go forward with your way of eating, then you'll see something that, hang on, is this the right way forward? So I'm going to try and sort of give you some insights into how to analyze those sorts of studies. So let me get the share going, because as ever, I do have some slides to go with this, and let me get that playing. The machine is rolling away. Excellent. So hopefully you can see my cursor. I'm going to move that off there. I'm going to move that out of the way there. Okay, so the talk is figures and fibre fallacies. So that corresponds to these two parts of the talk, looking at the figures from all these nutritional studies, and then using fibre as a particular example of looking at making sense from all the studies that have been issued with regard to fibre in the diet. So let's have a look at nutritional science in a broad sense to start with. And for all of us, we reach this stage of wondering, what should I eat? What's good for me? What's bad for me? What's a healthy diet? How should I lose weight? And over the years, we've all seen conflicting studies, conflicting information about what is exactly the right path to follow with your nutritional journey. And in a sense, when it comes to science generally, not just nutritional science, we have a perception that science should be black and white. It should be a case of what's right and what's wrong. In other words, if you see any output from science, be it nutritional science or any other branch of science, we all have a perception that there's an absoluteness, is that word? There's an absolute quality to the facts that come out from science. It's either right or wrong. So there's very much two sorts of facts, or one sort of fact and one sort of myth that goes with any branch of science. But unfortunately, and particularly with nutritional science, there's a huge grey area in the middle. And that really is a big problem, because it means it's very hard to disentangle from all the information that comes to us about what we should eat. It's very hard to work out, is it in the white right area, is it in the black wrong area, or is it one of these things that's just sitting somewhere in the middle in this very uncertain and grey area? And why should there be a grey area in nutritional science in particular? It's probably a grey area in all science, but I think in nutritional science, this grey area between right and wrong is quite a big area. And I think there's two main reasons why we have a grey area in nutritional science. First of all, nutrition is complicated. And I think that's fundamentally because we as humans are complicated beings. We're complicated organisms. So it's not simple. There aren't, in the same way with physics, there are certain laws of physics and absolutes. I think with nutrition, there are very few absolutes. And I think what's certainly the case with nutrition is that often there is no single form of nutrition that is optimal for everyone. So that adds to the complication of it. So that all contributes to the grey area. But a big contributor to the grey area in nutritional science is that nutrition involves companies making money. And I think a big part of the grey area is the fact that these companies want to sell you their foods. So there's a lot of money invested, if you like, in trying to provide nutritional evidence that each company's food is going to be ideally good for us, but certainly not bad for us. And I think that hugely creates or hugely contributes to this grey area that sits in the middle. And what I find interesting, and this is an interesting paper to read actually, it was in the Millbank Quarterly, which is a very interesting journal that has some interesting articles in it with regard health and health policy. And there's this article here looking at, from an historical perspective, from the 1950s onwards, when we first started to know that smoking was bad for us. There were the first robust studies really strongly indicating that smoking was correlated with cancer. How was it that it took 2 or 3 decades before that fully became established in the medical fraternity? And it looks at investment by the tobacco companies in research to try and make it so that people, at the very least, were confused about tobacco, and sufficiently confused that when robust science did come forward showing that it was linked to cancer, because there was sufficient doubt and confusion in the population, it was enough to make people doubt that research. It's a very interesting article because then it draws parallels. Are the food industry, or is the food industry, are the companies that make up the food industry, are they doing the same thing to us? Are they now making investments in research to try and just deliberately create this grey area, deliberately create this confusion? So although there might be some clear pointers with regard to nutrition, it gets watered down by all this confusion. And within that paper, they sort of make some very specific parallels between the smoking, the tobacco industry, and the food industry. And a few of these are quite interesting. These are the sort of bullet points of what they are suggesting. They have evidence of the food industry deliberately being involved in each of these methods of just making it a little bit more difficult for us as the consumer to know what is black and white, to throw us into this grey area that we've created. And the things like, for example, they focus on if governments intervene with food control too much, is that the nanny state? Is that food fascism? Is it trying to over control what we eat? And therefore, it's not in our interest to let them do that. That's a very useful ploy by some of the food industry. But the ones that particularly interest me is there's evidence, and a lot of evidence, that food manufacturers get involved in discrediting science that shows that their food products are not healthful, and they'll try and dismiss that as junk science. I'm going to give you some examples of that today. What they'll also do quite usefully is emphasize this idea that physical activity is a trump card over bad diet. In other words, the industry will try and convey to us that actually there is no such thing as good foods or bad food. You can exercise it off later. And of course, that's then hugely beneficial for what we might call junk food producers, because they're saying, well, actually, it's not the food that's bad for you. It's the fact that you're not doing exercise enough to burn off the calories from the food afterwards. And so a lot of the advice about exercising more actually is funded by the food industry, because it's actually trying to say to us, doesn't matter what you eat, come to McDonald's, come to KFC, as long as you exercise afterwards, you'll be absolutely fine. So that's really the context of where I'm coming from with regard to this grey area, that actually there's a lot of industry investment in this grey area to make us all uncertain, and that uncertainty then is a route for us then to make food choices that benefit the food industry. Let me give you an example of this, a fairly recent example of this. In 2019, towards the end of 2019, there was a publication, and it was called the Eat Lancet Guide to Eating, and it was from an organization called Food Planet Health. And it was a paper advising people on a healthful diet that was environmentally sustainable. So it all had very good motives, seemed very much a good contribution to debate on sustainable eating, sustainable food. And it was a very detailed diet, very detailed plan. It told you what percentage of things like whole grains and starchy vegetables and other vegetables and fruits and dairy food and so on you should be consuming to be healthful, but also to be doing it in a way that's sustainable for the planet. And it was supported by a paper in the medical journal The Lancet, which analysed this diet and made some very strong claims about how healthful this diet was. Now, what's interesting for me is some of the distilled information from that diet plan. And I've chosen 3 here specifically. The diet plan was suggesting it is good, not just okay, it is good to eat 50 grams of refined vegetable oils every day. Now, from my earlier talks, you know that these vegetable oils are not healthful. They are not good for you. They're pro-inflammatory. They're very strongly correlated with heart disease and cancer. But this diet suggests that it's very helpful to eat 50 grams of refined vegetable oils. It is incredible the amount of carbohydrate this diet is advocating. 800 grams or more of vegetables, fruits, grains, nuts, and cereals. 800 minimums. If you go for some of the numbers, it's over 1,000 grams per day, and that's a huge quantity of carbohydrate. And yet it only advocates eating 14 grams of meat. Well, I assure you, 14 grams of meat is not very much at all. It's hardly worth turning the oven on for 14 grams of meat. And that to me is a very intriguing balance of your macronutrients in the diet. But it becomes less intriguing when you look at who is funding Food Planet Health. And there are 50 companies. The ones I've highlighted in red are all companies that are either directly or indirectly involved in grain and cereal production. Either the actual production of the grain and the cereals, or the processing and packaging of the grain and cereals into processed foods, or companies producing fertilizers, pesticides, genetically modified crops to support that. So there's a huge investment from all these companies in promoting that 800 grams or more a day of the grain, cereals and vegetables, and also the 50 grams of vegetable oils, because we've got people like Unilever who are the big producers of these vegetable oils. So it is not surprising, therefore, that a diet that is backed by these organizations is going to be heavily favoring the produce that comes from these companies, either directly or indirectly. And it is no surprise that they're very low on meat, because none of those companies support meat farming, be it directly or indirectly, or very little involvement. So I'm already in my head saying, hang on, there's a skew here. We've got 50 companies that are involved in vegetable oils, grains and cereals, and we have a diet that is advocating those to the expense of an ancient traditional food, i.e. eating good quality meat. And when you actually then look at this diet, so independently, there are a few papers which then take this diet and then look at its content for key macro and micronutrients, particularly the micronutrients, it is actually deficient in those 8 vitamin and minerals. Well, actually, the omega-3 oils as well. So it's 3 vitamins, 4 minerals, and 1 essential oil. The diet as they're proposing it is actually deficient in those 8 nutrients. So to me, this is very much in that grey area. We've got a diet being advocated that's not helpful on the measure of deficiencies, but because it's being promoted by companies that support the key parts of that diet, that's how it's being passed to as in the public. So you have to be very careful when you look at studies, and in particular, who is populating that grey area of these food studies. And because of that, we as the consumer then see these oscillating headlines: meat is good for you, meat is bad for you, meat is good for you. And it's because of this ping pong match that's happening between the industries. And I can give you another very specific example of that. In 2007, there was a study by Vartanian et al. That looked at the association between fizzy sweetened drinks and obesity and health outcomes. And it was quite clear that people who consume the most of these sugared sweetened drinks had high levels of overweight and obesity, and also poorer outcomes on all sorts of health scores. That was 2007. 2008, another study comes out that actually says there's no correlation at all. But that study was funded by the American Beverage Association, and particularly Coca-Cola. So it just shows you this ping pong that goes on. The American Beverage Association did not like the study of 2007. So they came out with their own study in 2008. So, of course, us as consumers, we then get caught in this ping pong between those matches. One year in the Daily Mail, there'll be a headline, fizzy drinks are bad for you. The next year in the Daily Mail, the headline will be, fizzy drinks are good for you, or they're not bad for you at the very least. So industry funding is quite an important consideration in information allegedly nutritional science information that comes to us, but also adds to this confusion for these fundamental key questions. And of course, these talks that I've been doing are all about trying to give you some answers to these key questions. And hopefully you've twigged that I tend to, or I try to, where I can, to go from well-researched, well-designed study information, but how do we know what's a good study and what's a bad study? How do we know if a study is actually really just a manifestation of who paid for the study? Is it a study funded by the vegetable oil industry? Is it a study funded by the drinks industry? And so on. So we've got to be very careful with how we look at studies. That's my starting point, if you like, in the sense that how do we make sense of all of this? So let's come on to the body of the talk. And the body now is going to be in two sections. I'm going to first of all look at statistical studies, and then I'm going to look specifically at fibre. So in a sense, I'm setting the scene about how we can so easily be misled with the science of nutritional studies, and then show you how that has happened with fibre. Okay, so let's come on to the first half. Let's look at study shows. And I'm going to divide this into 4 sections. I'm going to give you some general ideas, general principles of scientific studies and how we use them in nutrition in particular. Then I'm going to give you 3 specific examples of how we can very easily be led down the garden path without realizing that's what's happening. And it's robust science, but it's science with a very specific objective at the end, and it catches the unwary. So let's look first of all at studies. Now, in science, in nutritional science, indeed in all sorts of health sciences, we will see in the mainstream media lots of articles like this, and all of these have a key starting point, and that is study shows. Each of these articles is study shows, study shows, study shows, study shows. Low-fat diet is not so good for you after all. Study shows diet changes alone can cure certain diseases, and so on. We get all these headlines. It could be in the Daily Mail, it could be in any magazine, any periodical. We will get these articles, which are meant to, or being conveyed to us as distilled knowledge from scientific studies that have been carried out. Well, there is a hierarchy of, if you like, robustness of food studies. And that hierarchy really conveys this idea that not all studies, not all scientific experiments on nutrition are created equal. Some are better than others. And let me just give you an insight into this basic hierarchy, because this is quite useful. An observation at the lowest part of this hierarchy is something along the lines of, somebody might make the observation that obese people tend to drink Diet Coke. It's just an observation, nothing more than that. But people could misinterpret that and think, well, is it the Diet Coke that's made them obese? Or is it just because obese people will latch onto any food that has diet attached to the label? But they make the observation that overweight and obese people tend to consume more Diet Coke than non-overweight people. That's a simple observation. And it's something that you or I might make just walking up and down the high street. If you go into the shopping centre in Milton Keynes and look at the profile of people, you might well see that the larger people are the ones that are snacking as they walk along. So you make an observation. A lot of nutritional science is based on this next rung on the study ladder. It's called epidemiology. And all of these really are centred on the participants in the study being given a questionnaire. And the fundamental point of this questionnaire is they are then asked to record what they ate. And it could be last week, last month, last year. And they're usually quite detailed, structured questionnaires. I'm going to show you a couple of examples of these during the talk. But essentially, it's asking you to recall what you've eaten over a specified period of time. And then clever statisticians then collate all these surveys from usually thousands of people to try and start looking for trends. Are the people that reported they ate a lot of eggs, do they have particular health outcomes? Or those that eat a lot of chocolate, do they have particular health outcomes? So they look at all these thousands of reports that are filled in by people and try and make deductions linking how certain entries are filled on those forms with health outcomes of those people. And that's epidemiology. In the next rung on the ladder is rather more robust. And this is where we take a group of people, divide them into 2. So you've got half a group doing one thing, half a group of doing another. And one of the halves, under supervision, have some sort of intervention. So as you'll see later, I look at a lot of studies where a group of people divided into 2, and half of them might be given a fibre supplement for a week, a month, 3 months, whatever period of time. They're given this fibre supplement for that period of time. And then at the end of the period of time, we look to see if there's any difference in the health outcomes of the two groups. And that's a rather more robust intervention, than epidemiology. Epidemiology, we just take a scatter approach. Let's ask somebody to remember what they've eaten over a period of time in the past. Intervention is all about, well, let's actually do something different for these people, make them do it for a period of time, and then see if that's made a difference to the health outcomes. They are a lot more expensive. They're a lot trickier to implement, because how do you know the people have actually done what you told them to do? If you told them to eat fibre, have they actually done that? How do you make sure there's not some other difference creeping in? But in principle, it's a much more robust way of looking at nutritional science. And the one at the top of the tree is what we call a meta-study, where clever people, usually statisticians, start looking at similar intervention studies and start saying, okay, well, each of the intervention studies might not have been able to do something for a particular length of time or with a particularly large number of people. But if you group together enough of those studies, can you start seeing something meaningful? So for example, again, if I go to the fibre example, we might have had 4 studies looking at fibre intervention, but none of those studies was either a particularly large number of people or for a long period of time. But is there some way we can put the results together from all of those studies to come up with something that's a little bit more robust and a little bit more meaningful? So we do have a very distinct hierarchy in terms of what studies are going to give us more meaningful information. The problem is, when you see your study shows headlines in the Daily Mail, say, we've got no idea where those studies were on that scale. Were they little more than observation? They're usually probably epidemiology. Rarely are they intervention or meta-studies. But of course, you don't know that. They just see a headline, study shows. And generally speaking, what you see in the Daily Mail will be the studies that are at this lower end of robustness of the scale here. They'll tend to be epidemiology rather than intervention or meta-studies. And one thing I will always say to anyone, whenever you see one of these headlines, does it defy common sense? So much epidemiology in food nowadays does seem to defy common sense. What do I mean by that? Well, let me give you a specific example. Meat is an ancient food. We've been eating meat for all the time we've been humans. But a lot of the epidemiology tends to suggest that meat eating is correlated with poor health outcomes, be it cancer, be it heart disease, and so on. Cancer and heart disease are modern diseases. Is it really a sensible suggestion that an ancient food causes a modern illness? Would it not be rather to think, is it not modern foods in the diet or modern ways of eating that are causing those modern illnesses rather than an ancient food? Is it not likely, therefore, to be more the synthetic refined vegetable oils, or the fact that we're eating a lot more processed food, or the fact that a lot more of our meat is processed rather than the meat itself? So sometimes when you see a study, particularly if it's epidemiology, you do have to step back a little bit and say, what would common sense tell me? And if you find there's something that it seems to contradict, the strength of the evidence has to be so much more to contradict common sense. If the epidemiology suggests something that fits in with common sense, then there's a case of, okay, that might be quite true. But if the epidemiology seems to go against common sense, I need to see evidence that's far, far more robust. So when you're looking at a study, you have to be very careful about, is it epidemiology? Is it intervention? Is it something stronger than that? And does it go against common sense? Now, let me show you how we can all be led a little bit astray with some of these studies. Let's look first of all at what I call the shoe size paradox, or the shoe size pitfall. I want you to imagine that we went to a group of children and we measured 2 things for those children. We measured their reading age and their shoe size. So I don't know how, let's say we took 2 or 3 dozen children, and for each of those children recorded reading age against shoe size. And let's plot those numbers on a graph. And as you might expect, there'll be some sort of quite strong relationship between them, because we know as a child gets older, their feet get bigger, so their shoes are likely to be larger. And we also know that as they get older, their reading age is likely to be greater. So there would seem to be a correlation between shoe size and reading age, which seems quite reasonable. The problem is, if you plotted a graph like that without somebody understanding the situation, you get a pushy parent descending into the situation thinking, well, my child has a reading age below where I want it to be, so I will just buy them bigger shoes. because the graph shows shoe size against reading age. It shows that a bigger shoe size seems to link to a higher reading age. So therefore, if your child has a lower reading age, buy them bigger shoes. Now, of course, we know that's nonsense because of the example I've chosen. But unfortunately, not just in nutritional science, but particularly in nutritional science, there's a lot of the shoe size paradox going on. And I would say sometimes quite willfully. Now, I try and use these little diagrams, I call them causation diagrams. And I want you to imagine age correlates with reading age. So the actual age, the birth age of a child will correlate very strongly with the reading age of that child. The older they are, the older the reading age will be, the greater the reading age. Equally, the older a child is, the bigger its shoe size. So therefore, that seems to create a relationship between reading age and shoe size, but it's all hinging on the fact that they're both linked to age. But if you are involved in the shoe size paradox, you've hidden age out of the equation, leaving this what we call spurious correlation between reading age and shoe size. And it's a branch of statistics in its own right, looking at spurious correlations. And there's an amazing website. Now, maybe it's because I'm a statistician that I find this website absolutely wonderful to play with. But there's a website that just lists spurious correlation after spurious correlation. I'm going to show you a few here just to show how mad and stupid this can be. Here are two curves on the same graph. One is per capita cheese consumption, and the black line is the number of people who died becoming tangled in their bed sheets. And look how close the curves match. It's a bit like my shoe size and reading age, of course, but no, now I can't imagine what the single factor is. But because the curves are so similar, if you didn't understand, if a Martian came down and looked at this, they'd say, well, we better stop selling cheese because it will actually reduce the number of people dying for tangling in their bed sheets. It's just a spurious correlation. Here's another one, divorce rate in Maine versus the consumption of margarine. Again, the curves are very similar. Again, if a Martian came down and didn't understand divorce rate or margarine, they would just say, well, if you want to cut the divorce rate, stop selling margarine. But these are completely spurious correlations. The curves of the graphs look so similar, but they are spurious correlations. And unfortunately, too much of nutritional science just falls into the same trap. In the 1960s, there was a study carried out called the 7 Countries Study. It was carried out by a guy called Ancel Keys, who's the father of the fat is bad hypothesis, pretty much. And what he did, he looked at the fat consumption from 7 countries, looking at population epidemiological data. So people in these countries were asked to fill out these questionnaires about how much fat they ate. And he recorded the levels of heart disease in those 7 countries. And what you can see is that looks a lovely sort of correlation. We've got this wonderful, as fat increases in the diet, we get more heart disease. It seems very nicely to demonstrate his hypothesis that fat is bad, fat causes heart disease. The problem is he wasn't very upfront with his data. He actually had the data from 22 countries, but he chose only to tabulate the data from 7. And what you can see is if you show the data from all 22 countries, the correlation disappears. So here we've got partly the shoe size paradox, but also just being naughty with your data, cherry picking your data, taking away the dots that don't fit your story so you get a clearer picture. And it goes on, the same data, had he plotted sugar in the diet versus heart disease with all 22 countries, he would have got a much stronger correlation. But he wasn't interested in that. He was a fat man. He was interested in fat being bad. So he ignored the sugar. And actually, when people did this to his data, there was a doctor of nutrition in the UK, Yudkin, who did this exact same graph plotting. And Ancel Keys destroyed him because he did not like this idea that it was anything other than fat, even though it was his own survey data that showed this strong correlation between sugar and heart disease. Ancel Keys didn't like it and basically destroyed the career of Yudkin because he contradicted his fat is bad hypothesis. And what's interesting, and this really is a spurious correlation, within the same data for the 22 countries, bearing in mind this was the 1960s, so TV ownership probably had wider varying levels between the various countries in the early 1960s. There was quite a strong correlation, certainly a stronger correlation than there was with fat consumption between TV ownership and heart disease, just simply from that epidemiological data. So you've got to be very careful with your epidemiological data where you're coming from. And there's one now which people don't like when I talk about this one. Again, it's a shoe size pitfall, is the question of, is moderate alcohol consumption good for you? And you may have this perception, you may have seen these studies which suggesting that some alcohol consumption is better for you than no alcohol consumption. And I want to, unfortunately, explode this myth because it is based on the shoe size paradox, the shoe size pitfall. So I want you to imagine we look at and we sort of compartmentalize alcohol consumption into three categories. You're either a low consumer, a moderate consumer, or a high consumer. And I want you to imagine, and the data was done for this study, what is the average life expectancy for people who are low consumers, moderate consumers, and high consumers of alcohol? And let's plot those graphs there. And this is what they found. So the length of the bar, or the longer the bar, indicates a longer life expectancy. And it would seem to suggest that those people who drank moderately rather than low or high levels of alcohol lived longer than either of the other groups. The highest alcohol consumption had the shortest life expectancy, low the next, and then moderate the longest. So therefore, you could come to the conclusion, looking at that data, that moderate alcohol consumption is good for you. And many people I speak to have this perception because they've seen or heard this study being reported in the media or similar studies. But there's a problem. If you take into account wealth of these people, you find something rather different, or not necessarily rather different, but rather closer to the explanation. If we now look at wealth in these three categories, we tend to find the wealthiest people are the ones who drink most moderately. In other words, people with lower wealth tend to be either low consumers of alcohol or high consumers of alcohol. It is actually the wealthiest people that are the moderate consumers. And wealth and health are very strongly correlated, be it to do with healthy lifestyles, access to healthcare, education. All of those factors contribute or are contributors to why wealthy people are healthy people. So in terms of my model here, there's a much better fit between life expectancy and wealth than there is between life expectancy and alcohol consumption. But there is also a correlation between alcohol consumption and wealth. So if we look at this study, doing my casting again into one of these causal models, wealth corresponds to alcohol consumption. The wealthier you are, the more moderate your consumption, the less wealthy, higher or lower your consumption. And wealth corresponds to health, life expectancy. So there's therefore going to be an implied relationship between those two. But if you hide that from your equation, you can then end up with an idea that it's only alcohol consumption that is linked to life expectancy. And that's not the case. So it's an example of the shoe size paradox, a shoe size pitfall, being applied to a nutritional study. So actually, unfortunately, all we can say is that wealth corresponds to health, and that wealth determines how much alcohol you drink. You can't say from that study that moderate consumption of alcohol is good for you. Let's talk about another paradox, what I call the too many balls in the air paradox. I want you to imagine a hypothetical study that we've got some babies, and we're going to do 4 things to them and try and work out what causes them to cry. We're going to take away the dummy, take away the teddy bear, take away the safety blanket, and just for good measure, give them a little electric shock. And then we're going to ask the question, what made him cry? And we're going to do that with enough babies so we've got something meaningful. And then the researcher doing this piece of work is going to ask the question from the data, what is it that was the bigger factor that made these babies cry? Was it taking away the dummy? Was it the electric shock? Or was it some other idea that the researcher was looking for? And because there's so many things going on, these studies are quite tricky to make sense of. So you have to involve statistical shenanigans to make sense of it all. Now that, because of the way I've given the example, does sound a little bit ludicrous. But unfortunately, this is something that, I don't know what the numbers are, but a very high percentage of the epidemiological studies in nutritional science do exactly this. They do exactly this. And they rely therefore on statistical shenanigans to come up with your answer. And here's one, and this is an important one in the context of these talks that I'm giving, because obviously these talks I'm giving are about following low carbohydrate diets. And you will see a lot of studies reported through the media throwing doubt, uncertainty that these diets are actually healthful. And here's one, it's from 2018. Low carb diets could shorten life, study suggests. Okay, it's a different way. It's not study shows, but the study suggests. And it's at the end of the headline rather than the beginning, but it's very much of this ilk. And a lot of people now send me these clips. People who are now doing low carbohydrate, they will send me these links because they'll say, Phil, have you seen this? What do you make of this? So imagine, and somebody did exactly do this to me 2 years ago or 18 months ago, August, well, nearly 2 years ago, August 2018. Here's my analysis of this particular study. Now, first of all, if you go to the study, so whenever I see one of these studies, that was the BBC, I think it was the BBC website, I find the link and I go to the study. And in the study, we've got this wonderful graph. And essentially what they did in this study, they got people to fill in one of these questionnaires, what you ate, and they divided the people into one of 5 groups, depending on how much carbohydrate they ate, as reported by these questionnaires. And they call them, I think, low, moderate, average, above average, and high consumers, I think. There were 5 groups. And what they did is they then said, okay, well, compared to the people who had 50% of their calories coming from carbohydrate, we'll call their health outcome 1, if you like, the reference point. How do people fare if they eat less carbohydrate and if they eat more carbohydrate? Now, bear in mind, there are only 5 groups. So there's one group sitting on here. So 2 groups giving the data here. So just 2 points, and they've got this nice line from 2 points. I don't necessarily believe that as a statistician. And we've got 2 groups here, the above average and the high consumers, again, giving us a nice straight line. So again, there's a bit of statistical shenanigans going on there. But essentially, because this is what we call the hazard ratio, this is in a sense of how many times more unhealthful, be it in terms of mortality or likely to develop disease, were these people who had the lower consumption of carbohydrate and the higher consumption of carbohydrate compared to this reference group at 50%. And what you'll see is that people who ate low carbohydrate, if you believe this graph, they had worse health outcomes. So the graph does seem to suggest and correspond to the headline. People who ate lower carbohydrate diets had poorer health outcomes. Correspondingly, or interestingly rather, people who ate higher carbohydrate diets also were unhealthful compared to the reference group, but not quite as bad. So the ones with the low and the very low carbohydrate consumption had worse outcomes compared to those that had the high carbohydrate consumption. So the graph seemed to support the headline. Okay, so then you start looking at the data. Well, if you start looking at the report, what's very interesting straight away is when they describe the people in the low carbohydrate, so that's the lowest of the 5 groups of carbohydrate consumption, they had the highest body mass index, they exercised the least, they smoked the most cigarettes, and they had the most diabetes. They were also a different age profile, a different gender, the balance of gender, and also a different racial mix to the other groups. Now, all of those things affect health outcomes. So immediately, as a statistician, I'm thinking, hang on, you're saying to me these people have got poor health outcomes because of their carbohydrate consumption, but actually you're then saying the 6 or 7 markers which are also indicators of poor health outcomes over and above, or certainly in addition to, the fact that they ate less carbohydrate. So this needs a lot of statistical shenanigans to decipher all of this. And I would say that no matter how clever the statistics is, how do you properly correct for all of these factors? So immediately I'm thinking, this isn't going to be robust data in the best of circumstances. So it's very definitely in our category of lots of things going on. Was it the dummy, the safety blanket, the teddy bear, or the electric shock that caused the baby to cry? And show me the statistical shenanigans you've had to use to separate all of this out. So immediately, without in a sense having to go any further, I would say, I'm not sure this study is as robust, but let's carry on. Let's have a look at the study. And what they did for this study is in a period of 2 years between 1987 and 1989, and then again between 1993 and 1995, they asked the participants, there were a lot of participants in this study, I think over 48,000, I think, in this study. They got them to fill out a food questionnaire, asking them to describe on average what they had eaten over the last year. Now, let's be blunt. If I asked you to describe what you had eaten on average over the last year, how do you think you'd cope? Let's look at some of these questions. Well, let's look at the rubric here. Please try to average your seasonal use of foods over the entire year. For example, if a food such as peaches are eaten 4 times a week during the approximate 3-month season that is in season, then the average use would be once a week. Now, imagine that for every seasonal food substance you ate, how reliable do you think that form would be? And this is going to be the basis of the statistical shenanigans that's claiming that low carb. I mean, I'm not going to say whether this could show even if low carbohydrate diets were good for you. I'm not saying that it's a one-way street. This isn't going to give us information of value either way. And then we asked them to do that, or this study asked those people to do it twice. But then they asked the question in 2013, was that person still alive? So here's another thing. Even if this was accurate, even if you could have perfect recall of what you ate for the last year on each of those occasions, is that truly representative of what you ate over this whole, what's this period, 87, 97, 07, 2000, that's nearly 25 years. So you're asked twice to report what you ate, and that's going to summarize what you ate for 25 years. So this really is not robust science. And it's very much like giving our babies the electric shocks, taking their blankets, taking their teddy bears, and taking the dummies away, than asking them when they're 20-year-olds, what was it that made you cry? It's a little bit tenuous, to say the least. So when it comes to studies like this, you have to be very wary about how robust they are. Now, once you accept the data from those data collection methods, which are very spurious, then the statistics in this paper are generally done quite robustly. But a house built on poor foundations is still an unsteady house. Doesn't matter how good your bricklaying is, if it's not good foundations, it's going to be a very fragile structure. And what's even more interesting about this study, there's a certain blinkedness about this confirmation bias. It was quite clear the people this study wanted to prove that low carbohydrate diets were bad for you, because in the data, if you look at the data, and I put the blindfold over the scientist here, if you actually look at the data in another way, go to the tables, they actually very convincingly say, so let's imagine I've overcome the hurdle of how the data is collected. It actually shows very nicely those on the lowest fat diet had the shortest life expectancy, but they weren't looking for that. And that was clear in the data. That was more robust in the data than anything else, but they weren't looking for it. So you have to be very, very, very careful. And here's another example, food-wise. I'm not sure the date. I did mean to look up the date, and I can't remember what year this study was done, but a study was carried out looking at the value of antioxidant supplements. And it was an intervention study. Remember hierarchy? This is a next rung up the ladder. It's not epidemiology. You're not asking people to fill in questionnaires. It's actually an intervention study. And half the group in this study were given vitamin C and vitamin D supplement pills. They were all given pills, but in this group they were placebos. They were just, I don't know what they're made of, but there's no active ingredient in them. In this group, they were pills of vitamin C and vitamin D, and I think beta carotene as well, 3 potential antioxidants. And at the end of the study period, they found in the study there was no difference in heart attacks, myocardial infarction, stroke, or cardiovascular disease between the two groups. So it would seem to suggest that taking these supplements had no impact on the two groups. However, when you look at the data, there's something glaringly obvious here. The researchers decided to use all the results from both groups, even though they found that up to a third of the people in each group didn't actually take the pills they were given. Now, it was equal in both, because obviously the groups didn't know whether they had the real pill or not. It was an average of about a third did not take the pill. But of course, that's hugely impactful on the result, because if these things do make a difference, but a third of people aren't taking them, that group of people are going to have, in total, a diminished response to the vitamin C and vitamin D pills. And in the analysis they didn't take that into account. They just said, well, all these people were given the pills. What was their health outcome? If you redo the maths and take out the third, of course, this third, because they're placebo pills, it doesn't make any difference they didn't take them. They're going to have the same results because they're placebo pills, or presumably no difference. But if you take out the third that didn't take the supplements in both groups, actually, you find there was a significant improvement in myocardial infarction, stroke, and cardiovascular disease in the supplemented group. So you have to be very, very careful with your statistical studies. So this is why we've got this hugely grey area. You begin to see why we get this grey area in nutritional science. It's so easy to miss sometimes what, for us, stepping back and looking at this study, particularly from a distance, is common sense. Take out the people who didn't actually take the pill. At the time of doing the study, the analysis was done ignoring that. So that's the too many balls in the air pitfall. And now let's look at what I call the unhealthy or the healthy person confounder. In a very simplistic model, there's two sorts of people: healthy people and unhealthy people. It's very broad, very generalist, but bear with me on this and I'll show you how this confounds your results. We've got people who absorb the healthy messages and people who ignore the healthy messages. So I want you to imagine, as indeed is the case, that in society we have 4 messages. Fiber's healthy, meat is unhealthy, low fat is healthy, exercise is good for you. And we see it in the press, we see it in the papers, we see it in magazines, you see it on your favorite websites, whatever. You see these messages all the time. Well, healthy people will absorb those messages because that's part of being healthy. If they're told fiber is healthy, they will eat fiber. If they're told meat is unhealthy, they'll probably cut down the meat consumption and so on. So unhealthy people will absorb those messages. Unhealthy people will by and large ignore those messages. They'll hear the messages, but they're making lifestyle choices not to do those things. So imagine now we conduct an epidemiological study, one of these studies where we ask people what they're doing and try and correlate that to their health outcomes. Let's say we have a man with a clipboard who starts asking questions of these 2 groups. Does fiber make any difference? Does meat make any difference? Does fat in the diet make any difference? He's got a problem because what's he measuring? Healthy people or unhealthy people, or those interventions? Now, let me give you an example of this. Let's imagine, and I'm going to give you an example which makes no sense, so therefore hopefully you can understand my argument. Let's say the Daily Mail had a little campaign that was saying stepping on the cracks in the pavement is good for you. It's healthy. Let's say they had a consistent message. And let's say, therefore, healthy people start doing that, or unhealthy people ignore that. So healthy people start stepping on cracks in the pavement. Along comes our man with a clipboard, and he looks at the healthiness of these healthy people and the unhealthy people. And he notices the healthy people are healthier. Because he noticed the healthy people were stepping on the cracks in the pavement, he concludes stepping on cracks in the pavement gives better health outcomes. But actually, all he may well have been measuring was the fact healthy people are healthy people and unhealthy people are unhealthy people. And if you have a pervading message in society that something is healthy, healthy people will do it. Or if something is healthy, unhealthy people won't do it. And that confounds your results. Now, this is hugely problematical in all epidemiological studies. If we have an epidemiological study looking at fiber, with such a strong message we've had for 50 years or more, that fiber is good for you, people who are healthy will eat more fiber. So if we just ask a question, do you eat fiber? And the answer is yes, you do, you are more likely to be healthy. And it may have nothing to do with the fiber. It may have lots to do with the fiber. We just don't know, but it's what we call a confounder. And this is really quite an important aspect. And a study I think I mentioned in my first talk, bacon gives you cancer, is a good example of where this confounder probably, almost certainly, rather than probably, almost certainly applies. Now, I want you again to imagine our 2 sorts of people. We've got our healthy people who have got the message bacon is bad for you, and we've got the unhealthy people who say, I love bacon. And that will manifest in their behavior. So the healthy people will not eat bacon, and the unhealthy people probably carry on eating bacon. The unhealthy people might eat it a little bit, but they eat it on average less than the unhealthy people because of the message we're consistently getting. Unhealthy people, of course, will do other unhealthy things. They'll smoke, they'll drink alcohol, they're probably less likely to engage in exercise. So the definition of an unhealthy person isn't just that they eat bacon, there's other things going on as well. So along comes our study, and we ask them to fill in their questionnaire. And one of the questions, I'm sure, is about bacon, if not several questions about bacon. And they fill in those questionnaires, and then in the study that results from those questionnaires, we conclude the people who didn't eat bacon are healthy and the people who do eat bacon are unhealthy. And because the study was looking at bacon, it's very easy to come to the conclusion that it was bacon that caused these people to be unhealthier. But actually, is it not more likely, or just as likely from a statistical point of view, that actually all you're really measuring is that healthy people get healthy food messages and unhealthy people ignore healthy food messages, irrespective whether the food is actually healthy or not. And that's an important confounder in most studies of not intervention. So if we gave people fiber over and above what they normally eat and see if that changed their health outcomes, then that starts to be a valid question. But just asking someone who has fiber in their diet normally and looking at their health outcomes is going to be confounded by the healthy person confounder. In this particular study that the Daily Mail referenced, I think I used these numbers in the first talk, the actual numbers were in the people who didn't eat bacon, the cancer risk was 5 in 100. For those who did eat bacon, high levels of bacon, it was 6 in 100. which isn't much of a difference. The relative risk, we represent that in something called the relative risk. In other words, 1.2, 5 times 1.2 gives you 6. It's like the ratio of one versus the other. That's what we call the relative risk. And one thing that I, as a statistician, will always get excited about is that when you're asking people to fill in these questionnaires, because they are so unreliable, you cannot conclude anything meaningful unless that relative risk is 2 or more. And even then, you've got to be very careful. It's called the Bradford Hill criteria. It's sort of statistical research that's been done over a number of decades. It was finely tuned on looking at the smoking data. And to give you a sense of perspective, if we did a study between smoking and non-smoking, that number would be 20, not 1.20, 20.0. So when it's a strong correlation, it's a big number. If it's less than 2, I'm sorry, it disappears in the roundings. And most of the epidemiological studies to do with nutrition, the relative risk is less than 2. So we're actually trying to read something in data that really isn't robust enough to show it. So a lot of the statistical work we look at is just not robust enough. And often it's because of the unhealthy or the healthy person confounder. So that's a little bit of a whistle-stop tour around some of the big pitfalls of these headlines. So if you start following a low-carb diet and you see a headline that says low-carb diets are bad for you, have a look at it, see if you can spot any of those pitfalls, or better still, send me the link and I'll have a look, or it may well be one I've already looked at, and I can point out to you, is it the shoe size fallacy? Is it the bald in the air fallacy? Is it the healthy person confounder fallacy? Or is it just playing with numbers in a way that just isn't going to give us a robust result? But a lot of food science does that. And that's the sort of science that ends up as these headlines. Let's just tie up a loose end, well, not necessarily loose end, but let me give you a little bit more detail. Remember early on in the talk, I talked about this Eat Lancet project, this food, planet, health way of eating. Let's see just how that fares in all of this. Well, it was an epidemiological study, so it's there on that rung of ladder, that hierarchy of studies. It's not as good as intervention. It's not a meta-study. It's filling in a questionnaire. And the study on which this was based, they got these people to fill in the questionnaire once in an 8-year period, and then asked the question in 2017 who was still alive. So again, we've got a little bit of that thing we had going on with the low carb study I went through before, a long gap, asking only once to fill in this questionnaire, a questionnaire asking them to record over a year what they ate, or retrospectively, what did you eat last year? And then expect that to be unchanged, and therefore anything that they answered in that questionnaire in that time frame was still being eaten in 2016, 2017, and that therefore caused their death if they died. So it's a bit of a leap of belief to be able to do that. And the study had all of these things going on because it was asking questions about or the diet was based on lots of fruit and vegetables, lots of fiber. We've got the healthy person indicator going on. The food questionnaire asks so many questions about so many different sorts of food. It's certainly the balls in the air, the baby with the dummy, the blanket, the teddy bear, the electric shock, all going on at once. And by blind sight, there's all sorts of things being ignored. It didn't ask about exercise. It didn't ask about genetic background, all the other factors that affect health outcomes. So it was very guilty of all of these things, this study that appeared in the Lancet. And what really is interesting for me is if you go to the study, rather than rely on the headline in the Daily Mail, and the graph may mean nothing to you, but what I've highlighted is the graph then looked at all-cause mortality. So what the study in the Lancet said was that certain causes of death, heart disease, stroke, and diabetes, were less likely in the people who had a diet that closely matched this planet Earth diet. What they didn't mention in the summary was that when actually looked at all-cause mortality, in other words, was the person alive or dead rather than did they die of these particular illnesses, there was absolutely no statistical difference. So eating this diet, which as we said was deficient of certain micronutrients anyway, overall, it did not change your chance of dying. It changed what you died of, but not your chance of dying. Yet the headline was, this diet is the one that's healthful, it sustains the planet, don't eat meat, eat lots of fruit and veg, eat lots of fiber. Actually, robustly, it shows if you believe the data. I mean, there's a huge gap here in my acceptance of the data, but even if you do accept the data, actually, you know what? It shows you there's no change to your chance of dying at the end of the time frame. And to me, it's me dying that matters, not what I necessarily die of. So we've got to be very careful with these nutritional studies. Okay, so let's move on to fibre. And I think this will actually go through fairly quickly, because what I'm going to do is I'm going to first of all talk a little bit about fibre, and then I'm going to quickly scoot through the evidence for and against fibre in the diet in a similar frame to how I've looked at some of those studies there. But let's go first of all to what is fibre, fibre 101, if you like. Well, fibre is a form of carbohydrate. And there are three forms of carbohydrate in our diet: sugars, starches, and fibre. And essentially what they are a measure of is they're all made of building blocks, these basic building blocks, glucose and fructose being two of the key building blocks, how long the chains of these building blocks are. So it's like a Lego set, how many Lego bricks are stuck together. In sugars, there's very few. In starches, there's a few more. In fibres, there's lots. You get these lots and long chains. And what happens in your body can digest these shorter chain sequences of these Lego bricks, and then we can absorb the Lego bricks into our digestion, giving us blood sugar. In these longer fiber chains, they're too long to be broken down enough in our digestion, so therefore they don't get absorbed. So fiber essentially is these long chains of molecules of sugar that cannot be broken down in the body and therefore fully absorbed. We tend to classify fibre as soluble or insoluble. It's slightly academic in terms of what I'm going to be talking about today, but just for sake of reference, we tend to find the soluble fibre tends to swell in water. Oats, beans, pulses, a lot of the fibre in fruit, and something called psyllium husk, which is the husk of the psyllium seed. It's the supplemental form of fibre. If you're taking fibre as a supplement, it's usually taken as psyllium husk. And the insoluble tends to be whole bran, whole grain. So the husk on grains and cereals, vegetables. So some of the fibre in some vegetables is soluble as well, but a lot of the vegetables is the insoluble. And again, some of the fibre in fruit is insoluble as well. But the key thing is, all of it, or as we thought, pretty much just ends up in the toilet. We don't digest it, or we part digest it, but it doesn't actually get absorbed into the blood, so it just passes through the bowel and ends up in the toilet. We now know that's not quite completely the picture. Some of it certainly does, or a lot of it does, but on its route through, the bacteria in our gut can act on the fibre. So although we don't have the chemical wherewithal to break it fully down, our bacteria do. And they can break the fibre down in something called short chain fatty acids, which we can absorb into our body. Now, we as primates do that a little bit. A lot of our primate cousins do it a lot. Chimpanzees, for example, they eat grass material, vegetable material, as we'd call it. So it's mostly carbohydrate. It's mostly this sort of plant fibre that they eat. But because they have a long hindgut, they have a lot of bacteria. A lot of these short chain fatty acids are produced, and that's what they absorb. So actually, a chimpanzee mostly absorbs fatty acids in its diet because it has a lot of bacteria that convert the plant fiber into fatty acids. So actually, chimpanzees eat a lot of fat. They don't eat the fat, they digest it as fat or absorb it as fat because their bacteria has made it into fat. We've got a very much shorter hindgut, we've got a few bacteria, we do this to a certain extent. That process is the process that produces hydrogen and methane. So bloatedness, gassiness is to do with the bacteria acting on your fibre, creating these short chain fatty acids. And because the short chain fatty acids can be absorbed, they are giving you calories. Whereas we used to think that eating fibre was 0 calories from the fibre because it went down the toilet pan, we now know that's not the case. And for some people, it could be that half the carbohydrate you eat as fibre will be absorbed effectively, the short chain fatty acids. So they do contribute to your calorie load. So that's what fibre is. What are the benefits? What are the alleged benefits of fibre? Well, before I talk about that specifically, here's the dietary guidelines that have just expired. There are new ones out this year, but these are the ones for Americans that lasted the 5-year period from 2015 to 2020. And it's interesting that people say to me, well, how much fibre should you eat? There's an answer in here. If you go to Appendix 6, talks about what an essential nutrient is, and it says other food components such as dietary fibre, they don't spell it as we do, such as dietary fibre, while not essential, are also considered to be nutrients. So in a sense, there's your answer. Fibre is not essential. I could end the talk there. I've proven my point. The Dietary Guidelines Americans say fibre is not essential. But the guidelines then contradict themselves in the body of the report because they start setting targets for how much fibre you should eat a day. But in the appendix, it's quite clear dietary fibre is not essential. Well, what are the benefits of, well, let's talk about history first of all of fibre. Now, in the 50s and 60s, this guy called Dennis Burkitt, he did a lot of analysis, epidemiological analysis, that's why I put these symbols here, looking at what people ate. And he came up with this hypothesis that people who had high fibre diets had fewer non-communicable diseases, such as cancer, heart disease, diabetes, and so on. He came up with this idea that high fibre gave you fewer of these diseases. So therefore, he became very much a pro-advocate of fibre in the diet. What he didn't do, it's a little bit like those studies I showed you with Ansel Keys, he didn't look at sugar in the diet, refined carbohydrates in the diet, synthetic oils in the diet. And had he done so, he would have found stronger correlations between these parts of the diet and the non-communicable diseases than fibre. Because he ignored them, he came up with this idea that it was fibre in the diet that was associated with these non-communicable diseases. And he got dubbed the fibre man. He was really the modern scientist that brought fibre to the fore in terms of it should be something that we eat. But there's a longer history of fibre, and there's two key players in the history of fibre. The first one is a lady called Ellen G. White, and then we've got John Harvey Kellogg of Kellogg's fame. Let's talk about, first of all, Ellen G. White. She is one of the founders of the Seventh-day Adventist Church. And she was, to say she was a bit puritanical would be like saying the Pope is a bit Catholic. She was absolutely adamant that, let's talk about food in particular, that animal flesh, milk and dairy were sins. To eat those was a sin. And actually, it was through men eating those things that there was impure thoughts, lust, greed. I mean, essentially, all the ills of the world were down to us eating all these things. And she was absolutely adamant about it. She was, I don't think veganism was a word she used, but she was effectively a vegan. She was probably one of the founding people of the modern vegan movement. Indeed, the Seventh-day Adventist Church is very much a plant-based diet church, and they do strongly advocate a plant-based diet. She was really the first person to talk about the wickedness of animal flesh and dairy produce in the diet. And John Harvey Kellogg fits into the equation because when he was a 12-year-old boy, he had to, because of family associations, he got the job of typing up the notes of Ellen G. White for her preachings. He was exposed to a lot of her thoughts about wickedness in men and so on. And he, in those formative years, obviously associated therefore eating all these foods with lustful thoughts in young men, he then linked fibre, the act of eating fibre, as being a purging process. You know, think about the physical act of eating lots of fibre, it does make you go to the toilet a lot. So he saw that as a purging process. So he refined this view that eating fibre was therefore purging the body of wickedness. So between him and Ellen G. White, they came up with the idea that fibre was important in the diet for purging your sins. And that was the start of fibre. It wasn't because science put it there, it's because religious fervour put it there. And of course, John Harvey Kellogg's fervour for fibre cleansing the diet has created a whole industry based around Kellogg's breakfast cereals. All our breakfast, a lot of the Kellogg's breakfast cereals are fortified with fibre. They're fortified to purge your sins, was the original sentiment of the Kellogg's fibre and the Kellogg's cornflakes, bran flakes, and so on. So that's sort of like a history, if you like. We've got some religious fervour introducing fibre as a thing, and then Dennis Burkitt actually trying to provide some science to justify that actually eating fibre does make you less prone to these non-communicable diseases. Well, let's look at fibre, what we think fibre is going to do. Let's do this quick skirt round the science of fibre. And there are 5 things here which I think most people, well, 4, most of them, most people will know about. Eating lots of fibre is good to give you your gut biodiversity. Fibre is good for constipation. Many people think fibre is good for fat loss. Many people think fibre is good for reducing the risk of colon cancer. And as I say, more recently, fibre is seen as an important source of short-chain fatty acids. So if you like, on the plus sheet, or the plus side of the balance sheet for fibre, we've got these 5 ideas. They are the things that fibre should be good for. So although it started in being in our 20th century frame of mind through people like Harvey Kellogg's as being a purger of sin, we actually now have some metabolic reasons, we think, as to why fibre should be in the diet. but what's the evidence? What's the evidence of those things? And I'm also, unfortunately, I'm going to have to, well, I say they're predicated on Kellogg's, and particularly this motivation, eating healthy whole grains. This is the really strong sentiment of Kellogg's. It's the husk around the grain that's going to give you the fiber, and that's the healthy bit. That's the bit that they wanted you to focus on. To do my full journey, I do have to throw at you 4 other things which are beginning to throw a certain amount of, is it as good as it's meant to be? Because there are studies that show fiber may not be so good for mineral absorption, hormone imbalance in women, causing diverticulitis, and I'll talk about that in a moment, and something we call small intestine bacterial overgrowth. So I'm just going to quickly scan through, and in a sense, I could come to the conclusions this very quickly, but I want to show you I'm coming to these conclusions by looking at studies that are mostly interventional. Remember my hierarchy where I had observation at the bottom, then epidemiology, most nutritional scientists epidemiology. What I'm about to say now is pretty much all coming from interventional studies. So these are the more robust studies of science. Let's look at gut biodiversity first. So what we mean by gut biodiversity, in our intestines, we have bacteria. And these are very important for us because there's a symbiotic relationship between the gut bacteria and us. These gut bacteria produce lots of useful substances that we absorb, and we help each other. We give them a nice, safe, warm environment, provide them with food, and they provide us with good nutrients, neurotransmitters, all sorts of things affecting mood and behavior as well as nutrition. And the variety, the biodiversity, the variety of your gut bacteria is called your alpha diversity. And we know pretty much the more diverse your gut bacteria are, the more healthful you will be. And so let's look at some studies. In 2018, So et al., what we mean by et al. Is that there's a lot of names on the paper. So was the first name on the paper, et al. Means and the others. So 2018 is the paper. And what they did, an interventional study in this paper, is that they took a group of people, divided them into 2. Half of them they gave fiber for a period of time, and then they looked at the gut biodiversity at the end of that time. And what they found was the people they supplemented with fiber, there was no difference in the gut biodiversity, the alpha diversity of the bacteria in the gut. Supplementing fiber made no difference. So these people were on an ordinary diet. They weren't encouraged to eat a normal amount, or they were just told to carry on eating as much or as little fiber as you normally ate. These were given more fiber, and there was no difference in the gut biodiversity at the end of the time. In 2013, David et al. Actually took a group of people, put them on a purely animal-based food diet, so no plant fiber at all, and compared those to a group who were allowed to eat their normal diet. And you know what? No difference in the gut biodiversity. They were a different species of bacteria. So the bacteria modified and seemed to modify quite quickly in response to the diet, but there was no difference in the diversity of the gut bacteria just by being on a carnivore diet. And then Svindinsky et al. In 2017, he looked at those on a low carbohydrate diet, and particularly multiple sclerosis patients on a keto diet. And he compared, they were both sets with multiple sclerosis patients, but half of them they put on the keto diet. And actually the ones on the keto diet had increased biodiversity of their gut bacteria. So that seemed to promote gut bacteria. So in terms of gut biodiversity, it was a green box, meaning it's potentially a benefit. I'm just going to put it as a grey box. I'm going to use a color coding: red harmful, green is beneficial, grey is neutral. It would seem to suggest that supplementing with fiber doesn't make any difference, and even diets low in fiber doesn't seem to be any difference in gut biodiversity. Okay, so let's look at the next one in my chain: constipation. So many people have this idea they need to take fiber to keep them regular, to keep their bowel movements in a regular fashion. So 2012, Yang did a study, and it was an interventional study, and he took a group of people divided into 2 who were constipated, and half the group he gave them extra fiber, and quite a lot of fiber. I can't remember what the numbers were, but it's quite a lot of fiber. At the end of the study period, the people on the fiber had no improvement in their constipation symptoms. And one symptom they did have a change in, they had more pain with their bowel movements. So frequency and ease of bowel movement, no difference, but they were more painful when they were given more fiber. I think the next study, so this is Sullivan et al. 2011, they did the same thing. found the same result. Giving constipated people fibre made no difference to, and I think they actually didn't report there was any increased pain either. I think there were no improvement with the fibre in the diet. And then a third study, Ho et al. In 2012, actually removed the fibre from half of their constipated group. And what they actually found was there was improvement on all scores: frequency, pain, bloating, straining, and anal bleed. All of those measures of constipation improved with those people on a removed fibre diet compared to people who just ate their normal amount of fibre. So the interventional studies suggest constipation. I'm going to make it grey then red in the sense that some of the studies show no difference, but there was that one interventional study that actually showed things were made worse. So, or actually the taking fibre out actually improved things. So I'm going to make that grey stroke red rather than green or just grey. It's going to be a mixture of the two. Let's look at fat loss. Does eating fibre help with fat loss? Well, again, I'm going to try and focus on interventional studies for this. And what have we got from interventional studies? Well, Howarth et al. In 2003, again, taking two groups of people and doing one thing to one half and not the other, he added fibre to half his experimental group over quite a long period of time. And then at the end of the period, measured to see whether there's any difference in fat loss between the two groups. None whatsoever. There were no other interventions. This is purely adding fibre. Adding fibre alone to adding extra fibre to their diet made no difference to their fat composition at the end of the study. So no change there. 2017, a big study. It was a review. It's one of these meta studies. They looked at 49 separate studies of fibre intervention with regard appetite and weight loss, and they consistently found in all 49 of the studies no significant measurable reduction in appetite or weight at the end of the study. So adding fibre from these studies did not make a difference to body weight or appetite. And the only studies that we have that seem to correlate eating more fibre with weight loss are these epidemiological studies that are hostage to the shoe size problem, the too many balls in the air problem, and the healthy person problem. They're fairly meaningless studies because of those issues. So as it stands, fibre, I can't have it as a green box. I'm going to make it a grey box because there just is no robust interventional evidence that it brings about fat loss. Let's look at colon cancer. There is a prevailing view that having lots of fibre in your diet reduces your risk of colon cancer. A lot of the studies are epidemiological, so they're hostage to these same problems. Let me try and look at what interventional studies there are. Well, Shatskin et al. In 2000 looked at polyps. Polyps are an important pre-indicator of colon cancer. They're an indicator. Not all polyps will lead to cancerous growth, but people with polyps will tend to people who do get colon cancer have usually had polyps as a preceding event, and they did a mix of a high fibre diet and a low fibre diet in people, and they looked at polyp formation, and lo and behold, at the end of the study period, there was no difference between the high fibre and the low fibre diet people. Alberts et al. Did exactly the same study, a bigger group of people. They found no difference. And then a third study, 2007, Lanza et al., they were so determined to try and find a difference that high fibre did help that they actually kept this study going for 8 years. And there was no difference in polyp formation or cancerous development because it was an 8-year study. There was meaningful data about whether they developed cancer. There was no difference. So the interventional data on colon cancer just isn't there. It's epidemiological, it's not interventional. So again, I'm going to make it a grey box. We're losing our green boxes very rapidly with fibre. Let's look at short chain fatty acids. Well, this one, there are studies to prove this, and I think there are several. I'm not sure I quote any here because I'm just going to give you the science that I've shown you in these previous talks. Short chain fatty acids, certainly as I showed you earlier when I was talking about fibre, bacteria in your gut convert fibre into short chain fatty acids. But as soon as you have glucose and fructose in your diet, simple sugars, processed food type sugars, it diminishes the bacteria in your gut, it diminishes your fatty acid production. So if your source of fibre is bringing sugar into the diet as well, one is counteracting the other. And if you're on a low carbohydrate diet, as I'm advocating, you'll have very little glucose, very little fructose, so your bacterial colony certainly isn't being reduced because of that. And the low carbohydrate diet means you live on ketones, and ketones are short chain fatty acids. So you've got them aplenty. You don't need the gut bacteria. They are producing it still. We know they're still producing, studies have proven that. But actually, the low carbohydrate diet is giving you an abundance of them because you're taking the sugar and the glucose and the fructose out of your diet. So short chain fatty acids are not a reason to eat fiber. On a low carbohydrate diet, you will get them. And on a high fiber diet that's also eating a lot of sugar, you won't get so many of them anyway. So all my green boxes have gone. Let's see if we've got any green boxes on these, which are potentially going to be red boxes. So SIBO, small intestine bacterial overgrowth. Now, here it's small intestine. There are useful bacteria in all parts of your gut, not just the large intestine, but the small intestine as well. Small intestine bacterial overgrowth is when actually the bacteria in the small intestine as the name suggests, become too rampant. And that causes bloating, gas, pain, bleeding, all sorts of issues that are very, very unpleasant in people, diarrhea, all sorts of problems. And the standard treatment, Dukovitz in 2007 produced a paper reviewing all the evidence of this. The current treatment for SIBO is to remove fiber, and it works, and there's robust clinical evidence showing that it does work. So I don't need to go any more than that, other than to say, if you've got SIBO, you do have to take fiber out of your diet. So it's a red flag for SIBO fiber. Let's look at diverticulitis. Diverticulitis is inflammation in the large bowel. And diverticulitis is inflammation of your diverticulosis. Now, diverticulosis is where you've got protrusions in the gut wall, where musculature of the lining of the gut wall begins to protrude through the lining of the wall. And diverticulosis, our friend Dennis Burke, remember him? He genuinely believed that you could treat diverticulosis by increasing the fiber in the diet. And he believed, therefore, if you treated diverticulosis, therefore you reduce your diverticulitis. Unfortunately, that again was based on epidemiological study. It was hostage to all of these confounding factors. And in fact, in 2012, Peary et al. Did an interventional study, and they noted that if you took fiber out of the diet, or if you added fiber to a diet, or had a diet that was high in fiber, you actually got worsened diverticulosis, and that led to worsened diverticulitis because the feces were larger. There was more straining of the muscle. More straining of the muscle gave more diverticulosis, and because of the high sugar in the diet, you got more inflammation in those, so you're more prone to diverticulitis. So unfortunately, Dennis Burkitt's idea has now been proved by interventional studies not to be the case. So unfortunately, eating fiber, if you're prone to diverticulitis, will make it worse. Let's look at hormones. Now, this is the only one where I have yet to find interventional studies for hormones. And so we're going to have to go on epidemiology. And the epidemiology for this shows that women, particularly women, and it was Gaskins in 2009 who did this epidemiological study, they noted that women on high fiber diets have less estrogen and progesterone in their circulation. Now, it's not an interventional study, and there could be other factors as well, but it's certainly a red flag. And in 2009, they identified that interventional studies should be considered for this, but I've not found any interventional studies. So there's a flag I'm going to raise here. I'm not going to make the box red because it's not an interventional study. I'm just going to make it grey. There's a question mark effectively. Finally, and this is the last one, and then we can summarize where we are with fiber. Mineral absorption. Well, unfortunately, this one, again, it is an interventional study, so we do know what's going on here. Torre et al. A long time ago, 1991, in fact, showed that 4 key minerals, zinc, calcium, magnesium, and iron, which are absorbed through the gut and absorbed into the circulation through the gut. If there is high fiber in the diet, fiber interferes with the absorption. So if you're eating a high fiber diet, you need to supplement with extra levels of zinc, calcium, magnesium, and iron to get those levels in your circulation. So unfortunately for mineral absorption, it's going to be a red box. So looking at interventional, okay, I'll sort of put my hand over that one because that's epidemiological, but looking at interventional studies, there were some green boxes on that when I started, but there aren't any now. So that's my view based on the evidence of fiber. But let me then try and say, okay, what's the message from that? Where would I go with that in the sense of what's my advice with regard eating fiber? Well, let me be a little bit pragmatic. There's my summary of my diagram that we had there. I think the thing to say is, if you're eating a high fiber diet because you think it's good for you, a large part of that is because of the Kellogg's effect, healthy whole grains, because they make a lot of profit out of healthy whole grains. So I probably am saying, don't stop eating fiber, but don't justify eating an expensive muesli because you think it's giving you a good fiber delivery. You've just got sucked into this message of whole grains are good for you. And the whole grain being the husk is delivering fiber. That's all the grain, the husk of the grain does, it delivers fiber. Well, actually, I'm generally, unless you've got diverticulitis and SIBO, then I would say be fairly neutral to fiber. If anything, slightly erring on the side, don't eat too much of it. So how I also translate that, if people come to me for guidance in helping them transition to a low carbohydrate lifestyle, I will pull them away from their expensive muesli or breakfast cereal. It's just profiteering by companies that want to exploit the fiber view, is my view. There is very little. Most mueslis are carbohydrate, processed, added sugar. Might be in the form of dried fruits, but it's still added sugar, and they're selling you on the ticket of fiber. What I'd also say is that, and here's a chart of the top high fiber foods. So this is a website taken from a website which is very much of the view fiber is good for you. What I will say to people again, if I'm helping them manage their transition to low carbohydrates, I will take them away from their high sugar tropical fruits, grains, cereals, pastas, their brown bread because they think it's being beneficial for the fiber, their pulses, the beans, and a lot of the starchy root vegetables. Because they're delivering carbohydrate, I don't want them in the diet. And the fact they might also be delivering fiber is a red herring. You're going to get fiber in my diet because I'm eating lots of the leafy green vegetables, the broccoli, the cauliflower, nuts, almonds, pecans, all those nuts. So you're still getting fiber. I'm not taking fiber completely out of the diet, but what I'm saying is don't use fiber as an excuse for justifying a high sugar citrus fruit, tropical fruit, your brown bread, your breakfast muesli. The fiber is a red herring because, as I say, the evidence really isn't that it's I've got to be careful because some people say to me, well, I do eat a bit of fiber because I do find it makes my going to the toilet habits better. Well, fine. If that works for you, works for you. But don't cling on to the idea that you need fiber unless you know for sure that it is the best course. Have you ever tried a low fiber diet? Do you know how your bowel will perform in a low fiber environment? So there we are. That's my study shows and fiber, looking at the statistical studies. Let me just finish with some quotes. I love this one from Mark Twain. Facts are stubborn, but statistics are rather more pliable. And as you've seen from some of the epidemiological studies, they are very pliable. So just be very careful of those. Statistics tells us that a person who eats rarely survives. Well, of course, we're all going to die. It's just a question of how and when. Statistics tells us that. And so statistics tells us a person who eats rarely survives. That was William Wallace. And statistics don't lie. It's the people who make up the statistics that lie. So just be aware of industry involvement in studies and the message that they want to get across. Okay, so there's my figures and fiber fallacies talk. With statistics, you can reveal everything but the truth.